At question 4 here, we have Alex invests 3,600 euros in an account that pays a nominal rate of 5.4% interest per year, compounding monthly. So that's important. The interest is added to the account at the end of each month. So that was just explaining it, giving you some explanation with it. And it says calculate the number of whole months it would take for Alex's investment to double. So we're going to be using our formula, and in this we would be using this formula over here, that A is equal to the capital 1 plus the rate of interest divided by 100, and you can use this to use K and then K in there. Okay, that's the formula that we have that we would use. Now we're looking at the number of months that it would take for it to double. So we're starting off with 3,600, and so it doubles to 7,200, and the rate of interest is 5.4, but because it's compounding monthly, there's 12 periods in every year, so this is going to be 100 times 12, or 1,200, and then we're going to have here 12n. So we're actually looking at the number of whole months. So this 12 times n will actually give you the number of whole months that it is, because n is the number of years. 12 times the number of years is the number of months. Okay, so that K is the number of compounding periods. So it's the number of periods that so in this case, because it's monthly, it's 12. If it was quarterly, it would be 4. If it was half yearly, it would be 6. If it's yearly, it's 1. Okay. So now, solving these equations are quite complicated. Not so easy to do. You can use logs for it, but I'm going to go through using the graphics calculator, see if we can get that working. Sometimes it's a little bit complicated to do that, but we'll see if we can get that going. So just simplify this equation down somewhat. That's going to be 7,000 divided by 3,600, so it's going to be 2 is equal to, this worked out to be what? 5.4 divided by 1,200. 1.0045, like that. And we've got 12n there. Now, because I'm going to replace this 12n, because this 12n is actually going to be the number of months, and that's what we're actually wanting to work out. We want to work out the number of whole months. I'm going to replace that 12n by x. All right, work out what x is, and that will actually be the answer that we want, because we want the number of whole months there. So we are going to actually put two equations into our graphical calculator. We're going to put y is equal to 2, that over there, and y is equal to 1.0045 to the x. And where they intersect should be your answer, should be the x value for it. So we get our calculator here, and I just can clear it. So I'm going to put y is equal to 2 in here, and then I'm going to put y is equal to 1.0045 to the power of x. I'm going to graph it. Now, in graphing it, we see that this is not yet reaching it. So we obviously got to go much further than here. All right, it's my window. I need to change my window around. I can see that we're going to be around 2. So I go to my window, and I can see here I'm going to need something bigger. So I'm going to start from, say, 0 to start with, and let me go down to, say, 200. Often this is just you've got to play around with this. You've got to try and get the right window that you want to start. Your y, that's be 0 and maybe go down up to 3. And say graph that. And here we're starting to get something that is around about what we want. Now you can push trace, and you can trace along to where you want to be. So you just go to trace. Now you go along to where about it is, that point over there. But that's not very accurate. That's not accurate enough yet. So you then go to zoom. You push zoom and you go to zoom in. You go down to 2 and you push enter. And you can zoom in. Now it will know to zoom into that intersection point. It will make that intersection point. So you go in, you push the enter, and now it's zooming into that intersection point. And you just do it a couple of times. And you see here that now you can see you're quite way off there. Can you see? You thought you were really accurate before, but in actual fact, when you zoom in, you're quite far out. So then you get closer to it. You go up. You just got to go up. I hope my calculator doesn't start playing up, because sometimes you just click up and you get it close to it. And then you go along. Sorry? Can't you just press the trace on intersection? Yes, but yeah, there could be. Show me that. I'll have a look and see. But this is getting it. So there we are there, and now we're getting it pretty close. And this is the value that we're wanting. We're wanting the x value. All right? It's 154.3505. All right? So we've got it pretty accurately. This is my value that I want. 154.3. That's the number of months that we actually dealing with. So x for this intersection point, x is equal to 154.3. But notice that it said the number of whole months. Okay. Now at 154, it wouldn't quite have reached there. You 0.3 into the next month. So the number of whole months would be the number of months. Months would be 155. The number of whole months that there would be. Yes, you can do it with logs. I can do the whole thing with logs also. So in this over here, yes, I can do this with logs. So if I wanted to do this with logs, I would use this step over here, and you would clear this. Now, with logs, you need to be able to go from your exponential form to your log form. Now, with this, and this is where in studies we haven't looked at this at all. It's not part of the curriculum. But if you want, I can show you and can explain this to you. But basically, you've got your exponential form. I'm running out of. Let me clear this. Just remind me of the equation that we're dealing with. It is going to be 2 equals 1.0045 to the 12n. And that's my formula. Huh? Now, in logs, you get a is equal to b to the power of c. You can put that into log form. In the log form of the equation, it would be the log of a to the c is equal to b. All right. Now, I don't really want you to worry too much about understanding that, but there is this. If you can remember this like you remember your name, then it works well. Because what we can therefore then do here, if we put that into this form, we're going to have that my sorry, I think I've got this wrong around. Have I got this wrong around here? It should be this. A is equal to B to the C. Therefore, C is equal to the log of A to the B, like that. That's the right formula. Okay, so I'm going to, if I look at this, my C is my 12n. All right, C is my 12n, so I'm going to get 12n. The B is this 1.05 and the 2 is this A. So I'm going to get the log of 2 to the base of 1.0045. So then I go to my calculator and I go to math and I push math and I go down to over here and we get this over here and we say enter and we get this, you see. I've got the log here and I've got to put this number in 1.0045, okay, and then I go to then I put in 2 and I say enter and I get 154.37.